Hello, everybody. So, welcome to today's class on today's revision lecture class. So, yeah, today we'll be starting the physics series of the revision lectures by SROKCMDP. Um, and then we'll be starting with modern physics. It's because it's closely aligned with the first chemistry chapter we did. So, let's get into the video. So, this is the plan for the chapter. The first video will be just discussing the basics, structure of atom. And then second video will be discussing radioactivity, and then the third video will be talking about the uses, and then medical, the nuclear plants, and then some safety measures, and biological effects and precautions also. So yes, first we'll be talking about the simple structure of atom. Yes. So this is the Bohr's atomic model, and all of us already know it. The way student, if you don't know this, then I think you wouldn't have paid attention in class or something. But then, yeah, basically, this is the Bohr's atomic model. In that we have the electrons revolving in orbits around the nucleus. The nucleus consists of protons and neutrons. So I have used red to denote, like in the series of lectures, I'll be using red to denote protons, and then black to denote neutrons, and then blue to denote electrons. Yes. So some general stuff. Mm, and then so we'll talk about some general things. So then the nucleus of an atom is much smaller than here. It's just over exaggerated model, but then in reality, the nucleus is much smaller than the entire atom. You can think of it equivalent like a cricket ball inside the entire stadium. So the stadium is the atoms, and then the cricket ball is the nucleus. Even that might not be very accurate, but just to give a feel of what it might be. And then the yeah, one more thing, the nucleus, you can see all protons are clustered together, but in electromagnetic theory, we learn that protons repel each other. So according to this theory, all these new uh, protons should fling away because the uh, protons repel each other. So the nucleus should be very unstable. But the nucleus is not like this. The protons are not just flying away from each other. It's because of this another force called strong nuclear force. And these forces only operate in ranges of 10 to the power of minus 15 meters. So these so they don't for these forces actually in these forces cannot like these forces cannot even act like toward the entire atom. They just can act, inside the very small nuclear distances. That's why electrons are not like just together. If it could be toward the entire atom, the electrons would also be just packed up. But anyway, this force, strong nuclear force, overcomes the electrostatic repulsion. Yeah, so the that's why the protons are together in the nucleus. And then there are some other uh, yeah, there are some other quantity like facts we need, which is basically charge of an electron, charge of a proton. You can just read it from your textbook. But the important thing from all of those is you just need to know that the mass of a neutron, m is for mass and n is neutron, is more than mass of proton by very very much little. Okay, it's and then you should know that the mass of an electron is very very like very very small. It's to be close to precise, it's 1800, around 1800 times smaller than that of proton. So you can think of a mass of proton plus mass of electron will be very close to mass of neutron, but you should just know that mass of proton is a little bit lesser than neutron, but it's comparable. That's why in atomic number we just think both of them add the same value in atomic number, which we'll be discussing right now. Yeah, no, now we'll be talking about notations. Uh, so in the atom, we use I've already told the black color circles represent neutrons and red color circles represent protons. And in this chapter, I'm just telling you don't see over here, you don't see that balance, the orbits in which electrons revolve around, because we are just talking about nucleus of an atom. So we don't need it really. So that's why I've not drawn it here. So yes, I think uh, we can move ahead. So then the number of, let's just count the number of protons in this in the left side atom. So 1, 2, 3, 4, 5, 6 protons, and then number of neutrons over here is 1, 2, 3, 4, 5, 6. So neutrons is 6. So essentially I've just given a C12 atom over here, nucleus of a C12 atom, and over here the number of protons we can quickly count: 1, 2, 3, 4, 5, 6, again 6, and number of neutrons: 1, 2, 3, 4, 5, 6. Okay, I made a mistake. That should be one more. 1, 2, 3, 4, 5, 6, 7. Yeah, and this is C13 atom basically. So where atomic number, or like usually when we represent an atom, we write it something like C12 6, C13 6. Yeah, we so then general notation is, and any atom can be represented, nucleus of an atom can just be represented by X, A, and below Z. This is the new notation. In the old notation, Z was on the right side, something like that. But yes, and over here, A represents mass number, and Z represents atomic number. So, what is atomic number? Atomic number is nothing but just the proton number, or you can just remember it as number of protons. So, atomic number in this atom, which is represented by Z. Yeah, many people get confused and write atomic numbers represented by A, but it's actually Z only. Don't get confused. An atomic number is just a proton number, which is 6. And then mass number. Mass number is nothing but proton number plus the number of neutrons. So 6 plus 6 is 12. So mass number is just atomic number plus the number of neutrons, or number of protons plus number of neutrons. So over here we get X, 6 plus 6, 12, comma 6, we have already done it. And here we get number of protons plus neutrons will be 6 plus 7, 13. Number of protons, or atomic number, will be 6. Okay. Now we'll be looking at isotopes, isobars, and isotones. So first we'll start with isotopes. So what is isotopes? Isotopes are nothing but just, they're just the number of protons in an atom determine what element it is. So, and the number of neutrons, they just determine the physical properties such as mass. They increase the mass, and so Isotopes are just same elements. That means all of their the number of protons in all of a given elements isotopes have the same number of protons. So this will have this number of protons equal to this. I mean, we are only looking at the left side figure. The first left side figure will have same number of protons as second, which will have same number of protons in turn of the third. And then, but the neutron number of neutrons can change. So isotopes are just elements with, they're defined as the elements with same atomic number but different mass number. So over here we are just seeing hydrogen's isotopes. Hydrogen are normal, I mean, the hydrogen which we see mostly like what we drink in water and all, they just have one proton. It's like they don't have any neutron. So proton is one and number of neutrons is zero. And over here you can see there's one red circle and one black circle. Red circle represents number of the proton and black circle represents neutron. And this is deuterium. This is called protium, deuterium. So these isotopes just have different names. And then tritium. So this is the isotope. This is the hydrogen isotope with the highest atomic number, which can be which is naturally occurring. Number of protons is one. Number of neutrons is two. So now we can just, using the notations we can also do for these isotopes. So the first one has number of protons plus neutrons, which is atomic number 1 plus 0 1, and then the proton number or atomic number is 1, so 1 comma 1 1. And then the second deuterium has 1 plus 1, which is equal to 2, and the proton number or atomic number is just 1. And third also, as we discussed, the number of protons will remain same, so atomic number is same. And then the neutrons, there is 2 neutrons, so 2 plus 1, which is equal to 3. Okay, now this is just a little bit more uh, complex atom. Yeah, over here again, when we do the same thing, since I told that these are isotopes, you should always check that there should be same number of protons. So if you count over here, wait, if you count over here on the left side of the second diagram, 1 2 3 4 5 6, there is 6 protons. So the number of protons is atomic number, which is 6. And then on the right side, you have 1 2 3 4 5 6 protons again. So isotopes always have same number of protons, so they have same atomic number. And then the number of neutrons over here, neutrons, I'll just write it here so we can add it up to this number, 1 2 3 4 5 6. And then number of neutrons here is 1 2 3 4 5 6 7. So atom mass number will be 6 plus 7, which is 13. And mass number over here will be 6 plus 6, which is 12. Okay, now we'll be discussing isobars. Oh, wait, there's one more thing I need to mention in isotopes. So there are two types of isotopes. One is stable isotopes. Stable isotopes is those isotopes which stable isotopes or isotopes which exist in uh, which have their number of protons nearly equal to the number of neutrons. In so they are like they're stable to radioactive decay. We'll be talking about radioactive decay in next video, but this is just for information. We will discuss this in detail. And then unstable nuclei are those ones which undergo radioactivity to turn into stable nucleus. So yes, that's another thing we have to discuss. So here we see C13. I mean, the excess carbon. C12 is a stable isotope, whereas C14, if I just put another neutron over here, it will become C14, and C14 is an unstable isotope. and it goes under nuclear, I mean, under radioactivity in order to turn stable. Okay, now we have isobars. Isobars, okay, isobars are nothing but they're just the elements which have the same, I mean, same mass number and different atomic number. So basically, if you count the number of particles inside the uh, nucleus of any two isobars, it will be equal, which means that protons and number of protons plus neutrons is equal to equal, which means mass number is equal in isotopes. So first, you can just do this small exercise. The first one on the left diagram, we have number of protons will be equal to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Sorry, I'm using too much of carbon here. Number of protons in the right, sorry, we'll count the number of neutrons first. It's 1, 2, 3, 4, 5, 6, 7, 8. Number of protons over here is 7, 2, 3, 4. And the number of neutrons over here is 7. So this will be x. This will be 6 comma 6 plus 8 is equals to 14. And this will be 6, 7 plus 7, 7, so equals 14. Then over here, so uh, as you can see over here, the mass number is same, but the atomic number is different. So these are called isobars, which have mass number, same mass number. Okay, over here, I'm just I'm not going to totally. I mean, I don't want to make 22 neutrons and 18 protons. It'll take so much time. So I just put a circle showing all the protons contained, and I just put a number, as you can see. So over here, we can name this nucleus as A, and then so if you add this both, you will get the mass number, which is 22 plus 18 and 40. And below is just the number of protons or atomic number, which is 18. And over here, again, 20 plus 20 is 40, but the number of protons here is 20. Okay, I have to denote it by some other name, otherwise this will be equal to this. So yeah, it's a 40 and 20. So basically, this is a calcium nucleus, and this is argon nucleus. They are both isobars because they have the same mass number. This mass number is same, they become isobars. Or number of protons plus neutrons are same, then they are isobars. Okay, now we'll be talking about one more concept which is given in our textbook, which is mirror isobars. So mirror isobars just have um, yeah, these are I'll name them MNN. So mirror isobars have the number of protons and neutrons exchanged. So over here we have 11 protons. So atomic number is 11, and we have 12 neutrons. So 11 plus 12, 23. We have atomic mass number is 23. Over here we have 12 protons, so atomic number is 12, and 12 plus 11, which is equal to 23, is mass number. So over here you can see they are isobars as the mass number is equal, but you can also see that the number of protons and neutrons are directly interchanged. So these types of elements are called uh, mirror isobars. Example is one which I gave here only, Mg23. This is actually magnesium. So you can put in, sorry, this is a magnesium, and this is sodium. So sodium 2311 and magnesium 2312 are mirror isobars. Now, next topic we'll be looking at is isotones. Okay, isotones are nothing but elements which have the same, uh, isotones are nothing but elements which have the same number of neutrons. So, isobars, we saw that they are the same number of protons. Isotones, uh, isotopes, we saw as same number of protons. Isotones is just same number of neutrons. So, in this example, let's name it P and this Q, and we'll call this R and S. Yeah, and so first we look at P and Q. They have number of neutrons is 2 and number of protons is 1, as you can see. And over here, number of neutrons is 2 and number of protons is also 2. So 2 plus 2 is going to be 4, which is the mass number of Q. And number of protons 2 is atomic number 2. And mass number over here is 3 and atomic number is 1. So just another small trick I'm telling. Your mass number you want to know, you can just count the number of things inside the uh, nucleus and you can put that. That's just mass number. And then over here, the number of, as I already told that I'll keep the number of as I already told, I'll keep the number of neutrons same. So you can see they are same. And you just add these both to get mass number 20 plus 19, 39. And proton atomic number is 19. Mass number 20 plus 20, 40. And atomic number is 20. So that's it for this video. And oh yeah, I forgot to mention the disclaimers in the beginning, but here are two disclaimers. One, I'm bound to make mistakes, so if I made any mistakes, please comment it in the relevant place, or you can just tell me verbally. And second is, you just don't see this, I mean, like, this is just for revision purpose, and I expect everyone should be reading the textbook, as we believe that in, as we believe that reading a book is still the best means of studying, and these videos are just for, if you want to just do it once, a revision once again, or you want to just get motivated or something like that. So thank you for watching, and we'll see you in the next part.